So finally, we arrive at the entire scientific method, and I'll take you through the scientific method step by step. Now, be aware of the fact that in real life, some of these steps may be combined, they may be done in a slightly different order, but in essence, this is the way every scientist does their work. The first step, of course, remember all knowledge begins with a question. So the first step in the scientific method is to ask a question or pose a problem or wonder, be curious about the physical universe. If you're asking a question that's not about the physical universe, then you're not dealing with science. Okay? So in science, we ask a question. The second step is to start with empiricism. Before you try to come up with an answer to that question, you collect data. You make general observations. You observe everything you possibly can about the problem or question that you're trying to solve. Step 3 is you use rationalism. You use deductive reasoning to come up with a possible answer to your question. We call that possible answer a hypothesis. You've probably heard hypothesis, and when I ask students what's a hypothesis, I always get the memorized response, an educated guess. But what does that really mean? Does that mean that you need to have a PhD before you can make a hypothesis? What exactly does it mean? Well, what it means is that you need to be educated about the problem. You first need to know, if you're going to make a scientific hypothesis, you need to know a lot about basic science, what we already understand about how the universe works, because your answer is going to have to fit with that. So you have to be educated about basic science. And then secondly, you have to be educated about the observations that we've discovered about that particular problem. So you need empirical knowledge about the problem, and you need general scientific knowledge. That's what an educated guess means. You can't simply say, oh, well, the moon is made of cheese, because science has proven quite conclusively that cheese wouldn't survive, wouldn't show the kind of features that the moon does. Okay. So in fact, what a hypothesis really is it's the antecedent of a deductive argument. An antecedent which, if it's true, would actually give you the consequence that you really observe. Okay? So if the moon is made of green cheese, then you wouldn't observe the things that we do observe on the moon, like craters and moon dust and so on. So this is what's going on in medical diagnosis. The patient has a fever, vomiting, diarrhea, right lower quadrant pain, abdominal rigidity, probably appendicitis. Appendicitis here is the hypothesis, a possible answer to the question of what is making this person sick. But remember, simply explaining the known observations doesn't prove the hypothesis, doesn't prove the antecedent, so we need to do something more, and that is to run tests. And this is the heart of science, if you want to pick a single heart. The idea that you do not believe any hypothesis, no matter how good it sounds, no matter who says it, no matter how many of the known observations it observes, you do not believe it as the answer until you test it. How do you test the hypothesis? As with everything else in science, you rely on our two sources of knowledge, rationalism and empiricism. And here's how you test it. There are two parts to every scientific test. The first part is you use deductive reasoning to come up with another consequent that's an observable prediction. Okay? You're saying if the hypothesis is true, then what's something that we should observe that we haven't that we haven't observed already? Because remember, we came up with the hypothesis to explain everything we could observe. We need something we haven't observed yet. So you're using deductive reasoning to come up with a new consequent of the antecedent to see if it's true. The obvious second part of the test is once you've made an observation of what you should observe if your hypothesis is true, then you use empiricism. Again, you go out and you look for that thing you predicted should be observable. You're now using observation, you're using empiricism the way we did in step 2, but it's a little different because now you're looking for something specific. In the first case, you were collecting as many observations as you could because you didn't know which one would be important. Now you're looking for that specific thing that you predicted. So what happens? Well, if you look and you look and you look and you look for that observation and you don't find it, then you have denied the consequent. You've said, if my hypothesis is true, then I should observe this. Well, I haven't observed this. I've looked many times, in many ways, every way I can think of, and I haven't observed it. So that gives me reason to think. In fact, 100%, I know that there's a problem with my hypothesis. Because remember, denying the consequent is logically valid. So I know there's a problem. My hypothesis may be completely wrong, or it may be incomplete. We'll see that in a couple of lessons. But I know there's a problem. With 100% certainty, I know that I do not yet have the final answer. The other possibility is that you affirm the consequent. You do actually observe the thing you predicted should be there. Now, that seems to support your hypothesis, but remember that what you've done is you've affirmed the consequent, and that's logically invalid, so you don't yet know if your hypothesis is true.